Let's start with example number 1. Okay, so example number 1, we have looked at it in our previous classes. It's saying that a continuous mixer mixes NaOH with H2O to produce an aqueous solution of NaOH. Right? Determine the composition and flow rate of product if the flow rate of NaOH is 1000 kg per hour and the ratio of flow rate of H2O to product solution is 0.9. So this example we have looked at before this, right? So first of all, whenever we have this kind of example questions, all questions for material balance, first of all we choose our basis. That is our step number 2. Step number 1, of course, we have to read the question and understand what the question is asking us to find. So here it says that find the composition, which is our mass fraction, and also the flow rate, the product flow rate. What is the product flow rate? So first of all, let's say we say our basis. Okay, second step, basis. It is given in our question that we have a flow rate of NaOH of 1000 kg per hour. So we can say that our basis is 1000 kg per hour. Okay, and then after we have done that, after we know our basis, then the most important thing is that to draw and label our flow chart. So again, you can just draw a box. Say this is our mixer. And then we have an input of NaOH. So I just put here F1 for, this is the stream for NaOH. F1 is equal to, I know that it is 1000 kg per hour. Okay, so again, I would like to stress that this F1 is just a symbol, it's just a labeling. If you want to put F1, M1, B1, it's up to you, it's just a label. Sometimes you can also put that here is F and NaOH, meaning that the feed of NaOH. Okay, so it's up to you. Okay, or you can also put M and NaOH. As long as you know what does this represents. If I put here F1, I know that my F1 here is for feed of NaOH. Okay, and then I have a second feed coming in, which is my feed of water. So I can put here F2, and the value I don't know, so I just put F2. Okay, but I know that this is the stream for H2O, and then coming out, it's a solution of NaOH, meaning that I can put here P as a product, or you can put any other symbol, it's up to you. And I know here I have a solution of NaOH, meaning that I have water and NaOH in my product stream. So I can say here solution NaOH. Okay, this is just, I'm labeling the stream. I'm labeling, so I know that this is for NaOH, this is for water, and this is for solution NaOH. But here, since I say this is for solution NaOH, I know that there must be a composition of water and NaOH in terms of mass fraction. So that's why I can write here under the P, my W, H2O. I don't know. And also I have W and NaOH. Okay, so these are the two mass fraction that I have. And then we also say that completely labeled, meaning that whatever other information you have to put in the questions. So the question is saying that you have a relationship between your water and your NaOH solution, which is that I know that F2 over P is equal to 0.9. I can also write F2 is equal to 0.9 P. Okay, so So based on the question, this is all the labeling I can do, and this is my completely labeled flowchart. That is step number 3. Step number 4 is that we do degree of freedom analysis. So again, the formula for degree of freedom analysis, ND is equal to NU minus ND. So NU is the number of unknown. If you look at our flowchart, we know that we don't know the flow rate for the water. We don't know the flow rate of our product stream, and we also don't know the mass composition, the mass fraction of water and NOH in our product stream. So I say that my NU is equal to 4. Now, in order for me to solve for ND, I need to find my independent equation. So to find independent equation, first of all, the most easiest way for you to decide how many independent equations you have is to look at how many components or species you have in your system. Meaning that what different chemical you have in your system. So if I look at here, I have NaOH here, I have water here, and then I have NaOH here and water here. So I only have 2 different species in my system. So I know that my Ne, the number of independent equation I can write based on this chemical composition, chemical component that I have is 2. Okay, and then the next step is that we find any explicit relation. Explicit relation meaning that is how we relate our feed to our product. This is the information given in the question. So I say that I have another one. And then still I have not enough. I still have degree of freedom equal to 1 because 4 minus 3 is equal to 1. So I go back again and I try to find if I have any other relationship. And then I find that I have this relationship, which is the relationship of mass fraction. We say that mass fraction must always equal to 1. Doesn't matter how many components you have, if you add all the back fraction, it must always equal to 1. Meaning that WH2O plus WNaOH must equal to 1. So this is another independent equation. So I have plus 1 here. So I have 4 minus 4, so I get my Nu is equal to 0. When Nu is equal to 0, we say that this question is solvable. So now that is step number 4. Now today we're going to be looking at step number 5. So step number 5, before we do step number 5, we have to go back to our first and second lecture. Okay. Remember we have this general material balance equation, right? So I've mentioned that we have type of system, we have type of process, and also we have either steady state or unsteady state. Based on that, we can simplify our general equation. So if you look at here, this is definitely continuous process, open system because we have input and output, and as I mentioned, we'll be only dealing with steady state. So we have no accumulation, and this is a non-reactive system. So definitely we have no generation and no consumption. So the only thing left is that input minus output is equal to 0 from our general equation, or we can also write input is equal to output. Right? I just carry over output to the other side of this equal sign. Okay, so this is our general equation now for this system. Input equal to output, meaning that whatever is going in must come out because there is no accumulation in our mixer. Nothing is staying in our mixer. So now, since we know that input is equal to output, so we can start to write our equations. Now here you will see what I mean by independent and dependent equation. So you have various methods on solving this problem. Degree of freedom is just to know whether you can solve the problem or not, so that you don't waste your time trying to solve an unsolvable question. So now you know that this is solvable. So step number 5 is that we start writing our equation. So what we can do is that you have several options. The first option is that we see that we do balance overall. Okay. Let's say I say we do overall balance. Overall balance meaning that whatever is coming in is going out. So if we go back to our flow chart, I know that I have an average of 1,000. So I say that 1,000 is coming in. Plus, if you have anything coming in again, yes, I have my flow rate of water is also coming in. So I add my F2. Anything else coming in? No, I only have 1,000 and F2 coming in. So this is my input. Right? Now I want to equal it with my output. Okay, so the output, I know that the only thing coming out of the mixer is my P, the flow rate of product. So it's equal to P. So this is our first equation. Right? Input equal to output. Now we can do, let's say I do balance on H2O. Okay, I just want to do balance on H2O. Everything else I'm ignoring. To balance on H2O, I go back to my flow chart. I see that here I don't have any H2O. This stream is only for NaOH, so I cannot include my balance for H2O. I go here, I see that I have H2O coming in here, and the whole stream here is only H2O. So I can say that on the input side I have F2. Okay, nothing else coming out. So that is my input side is equal to. Now I look at my solution NaOH. I know that in here there is water, because we say that for NaOH solution we have NaOH and water. That is how a solution is made. So I know that the mass fraction of the composition of water in this stream is that this is the fraction. So I see that W is to O and times the total flow rate, which is our P. Okay, that is my second equation that I can make. The same thing I say I want to do balance on. So I put here balance on NaOH. So the same thing, I go back to my flowchart. I see that for NaOH, I know that it is 1,000 on the input side is equal to mass fraction of NaOH. So W NaOH, and then times with my P. Ready? This is my third equation. Okay, so I can do balance overall, balance on H2O, balance on NaOH. So these are the equations that we say we have to write in our step 1. But we also have some other equation that we write because our explicit relation. So I can say that other equation F2 is equal to 0.9 P. This is my fourth equation. And I can also write my fifth equation here. WH2O plus WNaOH is equal to 1. So this is my fifth equation. Okay, so now I have all the possible equations I can write. So now, before we start solving here, I just like to make sure you understand that this is independent equation. Okay, this is independent equation. We have 1, 2 and 3. Even though we have 3 equations, only 2 are dependent equations. Okay, so how do we know whether only 1 or 2 are dependent equation? You can just add in equation 2 plus equation 3. Okay, if you have equation 2 plus equation 3, it will get equation 1. Okay, so if I see here 1000, if I just add in equation 2 and equation 3, I know that I can add 1000 plus F2, so I know 1000 plus F2 is equal to W is to O plus P times W and AOH times P. And I know this whole term because this times this, I will get a of P. So again, if you see here, this new equation is equal to this equation number 1. So that is why we say that only 2 of them are independent and 1 of them are dependent on the other. Okay, so that is the meaning why we say that we have to write independent equation. It does not matter how many equations you can write, right? The most important thing is that how many independent equations. Okay, so I hope you understand this. If you don't understand, you can always ask questions. So now we have all the equations that we have written. So the next step is that we just have to solve the equation. Okay, so how do we start solving the equation? So let's say we have this equation. Okay, I'll start with this equation. Balance on H2O. Okay, so I'll I'll start with the balance of H2O. I know I write in F2 is equal to W H2O times P. And I also know that my F2 is equal to 0.9 P. So if I substitute again, I get 0.9 P. Okay, instead of this F2, I put this value is equal to WH2O times P. So if I cancel out my P and P, I know that WH2O is equal to 0.9. So I have gotten one of the value here. Okay, I have gotten this value. Now, if I want to find the value of W and AOH, I know that WH2O plus W and AOH is equal to 1. And I know, so I can get W and AOH is equal to 1 minus, this is value of 0.9. I can get the value of 0.1. So I have gotten this value as well. So 2 unknowns are solved. Right? And then to solve for the rest. Okay? So I can use my overall balance. I know that F2 plus 1000 is equal to P. Again, I know that my F2 is equal to 0.9, so I can just write 0.9 P plus 1000 is equal to P. Okay, so you minus and you get P is equal to 10,000 kg per hour. Okay, remember, unit is very, very important. So I have gotten this value, right? And then finally, the only value I don't have is my F2 value, but it is easy because I know that I have this formula. So F2 is equal to 0.9 times the value of V, which is 10,000. So I get a value of 9,000 kg per hour. So I have gotten the value of FT. Now that this is one way to solve this question. Let's say if you want to solve other way. So for example, let's say I want to do balance on NaOH. Can you do that? Yes, you can do whatever equation that is possible to solve. Usually what we do that, we try to find the easiest way to solve our question. Okay, so that is how we solve for example number 1. For example number 2, 2 methanol water mixture are contained in a separate flask. The first mixture contains 40 weight percent of methanol and the second contains 70 weight percent of methanol. If 200 gram of this first mixture is combined with 150 of the second, what are the mass and composition of the product? Okay, so again, it's asking us to find the value of mass and composition. Okay, basis, since I have two value, I'm using both value 200 gram and 150 gram. Okay, this is my F1 is equal to 200 gram, and I know that I have 40% or 0.4 weight percent methanol, and I have the rest is water, and then this is my P2 is equal to 150 gram, and then I have 70% or 0.7 methanol and also 0.3 water, and I have product with weight fraction of methanol and weight fraction of water. So here my ND, after I did find my unknowns, after I did find my independent equation, is equal to 0. So this question is solvable. Okay. So again, this system is open system, continuous system, and also steady state system, meaning that our general equation will become input is equal to output. So I start with writing my equation. So I start with balance overall. Balance overall meaning that 200 plus 150 is equal to P. This is my first equation. Then I do balance on methanol. Balance on methanol is that 0.4 times 200 plus 0.7 plus times 150 is equal to Wm times P. That is my second equation. My third equation is balance on water. So balance on water is that 0.6 times 200 plus 0.3 times 150 is equal to W of water times P. This is my third equation. Okay? And I don't have any other equation that I can make other than this equation, which is W m plus W water is equal to 1. This is my fourth equation. Again, this equation 1, 2, and 3 are related, so you only have independent equation. So if you look at equation number 1, I can automatically get the value of P. So I know that P is equal to 350 grams. So I I have already solved one of the variable, which is my P. The only thing left is to solve for methanol and water and to find the weight fraction of methanol and weight fraction of water. So if you look at this equation, since I know the value of P, right, I can substitute here instead of putting with P, I can put here 350. Known value, the only unknown. So I can get my weight fraction of methanol is equal to 0.529 or 53. Okay, depending on your decimal point. 2 decimal point is also acceptable, depending on your situation. If you feel that you want to put 3 decimal point, it's also acceptable. 29, okay, or 28. Since I've gotten the value of my weight fraction of methanol, I know that I can find the weight fraction of water, which is Wm plus W water is equal to 1. So my W water is going to be equal to 1 minus 0.59 equal to 0.46. Right? Yeah. Okay. So this is my final answer. So I've gotten the value of P, I've gotten the value of Wm, and I've gotten the value of W. So that is how to solve for example number 2. Example number 3 is saying that spent acid from a nitrating process contains 21% of sulfuric acid, 55% of nitric acid, and 24% of water by weight. The stream is to be strengthened by addition of number 1, concentrated sulfuric acid containing 93% sulfuric acid and 7% water, and with number 2, concentrated nitric acid containing 90% nitric acid and 10% water. To form a stream composition is 62% sulfuric acid, 28% nitric acid, and 10% water. If 1,000 pounds per hour of product stream is desired, find the flow rate of the other 3 streams. Okay, so you have 4 streams here. So it's a little bit complicated. Again, this is a mixer. So let's say this is your stream number 1. So for stream number 1 is that you have a spent acid. Okay, so I'll just write here F1, and I know that my composition is 0.2 sulfuric acid, 0.55 nitric acid, and 0.24 water. So if you look at here, all these things will add up to 1. So this is your mass preparation for stream number 1. It is added with concentrated sulfuric acid, which has, so this is your F2, okay, which has 0.93 sulfuric acid, and the rest is water, which is 0.07 water. That is your stream number 1, stream number 2, and then it's also added with your concentrated nitric acid, which has F3, which has 0.9 nitric acid, and we have 0.1 water to form a stream with a composition of, this is your P, and we know that it is 1,000 pounds per hour. 0.62 of sulfuric acid, 0.28 of nitric acid, and 0.10 of water. So this is the mixing process. So now if you see here, it's a little bit complicated because we have 4 streams and 1, 2, 3 types of component in our system. Okay. So if you were to write the material balance, okay, if you were to write the degree of freedom analysis, if you look at here, the only unknown that we have here is your flow rate of stream number 1, flow rate of stream number 2, and flow rate of stream number 3. So we have your NU is equal to 3, and you can see that our independent equation, we have 3 components, so we can have 3 independent equations. So automatically, the degree of freedom is equal to 0, so that we can solve this problem. Okay, so please go back, try to solve this problem. I have given you information until now. Okay, so I want you to try to write whatever equations you have. Remember, this system is open system, continuous system, and also steady state system. So we have only equation is that input is equal to output. So if you do balance on sulfuric acid, balance on citric acid, balance on water, and balance of overall, you will have 4 equations. From that 4 equations, you will be able to solve. And tomorrow, I want you to give me the answer. Okay, tomorrow morning before we start our next topic, give me the answer, and we'll see whether you are right or wrong. So for example, number 4 is saying that sludge is a wet solid that results from processing in municipal sewage system. The sludge has to be dried before it can be composted or otherwise handled. If a sludge containing 70% water and 30% solid is passed through a dryer and the resulting product contains 25% water, how much water is evaporated per ton of sludge sent to the dryer? So it's basically a drying process. So again, basis is, I know that from the question, the last line, the question saying that how much water is evaporated per ton of sludge sand. So I know that I'm dealing with 1 ton of sludge. 1 ton is also equal to 1000 kg. So I know that this is my basis. So when you are going into a dryer, you will have your sludge going in, and I know that my sludge has a composition of 1000 kg. Okay, and then the composition of the sludge going in is 70% water, so I can put 0.7% water and 30% solid, so 0.3 solid as. Okay, it is going through a dryer, so it is coming out. Okay, my P1, I put P1 here because I know that there are 2 streams coming out. My first stream coming out has a composition of 0.25 water, and the rest 0.75 is my solid. Okay, then I know that the concept of dryer is that when you have mass coming in, a wet solid, it will have some moisture containing, and most of it water will be evaporated. So I know my P2 here is only H2O. Okay, the composition is all 100% water. So this is my question. So anybody have any idea what is the degree of freedom for this question? Any idea? what is your number of unknown here? Anyone?
2.
Number of unknown is 2. Okay. And u equal to 2. Number of independent equation?
2.
2 as well. What are the independent equation? How did you come up with 2?
2 species, water and solid.
Okay, so you have one is the water and the one is the solid. So you have 2 species in your system. So you can see that our degree of freedom is equal to 0. So this question can be solved. So again, open system, continuous system, and also steady state system. So we can say that input is equal to output. So if I do overall balance on the overall, I know that 1000 is equal to P1 plus P2. Okay, that is my overall balance. If I do balance on water, I know that 0.7 times 1000 is equal to P2 plus 0.25 times P1. Okay, that is my second equation. And if I do balance on solid, so I know that it is 0.3 times 1000 is equal to, there is no solid in our P2, so it's going to be 0.75 times P1. Okay, so I have 3 equations. 2 of them are independent, one of them is dependent. And from this equation, I can straight away get my value of P1 is equal to 400 dg. Okay. And then my P2 here, if I just put here, P1 is 400, then I can get P2 is equal to 1000 minus 400. So I can get value of P2 is 6600. Okay. So that is all for example number